Hi, my name is Ron Godovic. I'm the CEO of WindStax Energy based in Pittsburgh, Pennsylvania. Thanks for viewing our slides today. I'm going to talk to you about one of our projects that I think you're going to be very interested in learning how we are combining small wind energy and solar and battery storage with DC distribution in running a trucking terminal in the Midwest. So stick with me, and I'll be happy to take questions at the end. WindStax Energy manufactures the largest vertical axis wind turbines in the United States. Our patented design has over 2 million operating hours at this point. We've done projects for the past 10 years as far away as California and Virginia, but mostly in the Midwest. Our turbines have a very small footprint. They're silent and they can accept wind from any direction. That makes them very easy to site in locations that normally you could not install a wind turbine for height restrictions or sound restrictions, etc. Our turbines, as you can see here, these are 60-foot turbines, 8 of them at the entrance to Pitt, Ohio, in Parma, Ohio, just south of Cleveland. As you can see, they make a pretty grand statement at the entrance to their company's commitment to renewable energy. These turbines are made of steel and aluminum, and even the foundations are helical piles. So these are, in fact, the only 100% recyclable wind turbines currently on the market. Pitt, Ohio is a family-run trucking business based in Pittsburgh, and for the past 35 years has continued to grow throughout the Mid-Atlantic and Midwest into really what considered to be a leader in regional and national logistics services and sustainability in the transportation industry. The company has been an early adopter of advanced distribution energy resources, or DER, as we know them, really using renewable energy at its terminals to help achieve its sustainability goals. The Pitt, Ohio, Cleveland terminal that we're going to talk about today applies the best practices in LEED certified construction and renewable energy production at its newest terminal. But this is the company's second terminal to use a major wind and solar-based microgrid in collaboration with WindStax. Pitt, Ohio previously worked with us at its Pittsburgh, PA terminal, here based in Harmarville, PA. While the Harmarville trucking terminal had a modest 50 kW solar panels and 2 60-foot WindStax vertical turbines and about 60 kWh of battery storage, Parma, the facility south of Cleveland, takes this to a whole new level. This project is approximately 10 times the scale of renewable energy and takes distribution throughout the facility rather than just an area in the trucking terminal as it was in Harmarville. So the microgrid really combines solar and wind energy with battery to power interior and exterior loads throughout the entire facility. Awarded several US patents, the high voltage DC distribution to the fixture design uses renewable energy with maximum efficiency. Utility power is available seamlessly as a backup, and excess renewable energy is sent to the grid. Wind and solar production combined with massive energy storage capacity allows the terminal to function autonomously, independent of the grid, essentially indefinitely, as long as there's wind and sun. This type of energy resilience and carbon offset is really unprecedented in the trucking industry, and it's a major competitive advantage to Pitt, Ohio and its customers. In Ohio, only 2.5% of the state's net electricity is generated by renewable energy. Coal fuels 58% of generation. natural gas 24%, and nuclear energy accounts for another 15%. But the limitations of solar and wind incentives in Ohio are really well known. This is an area where fracking is common, and natural gas generation is also common and relatively inexpensive. But in this situation, this made perfect sense for this customer. This facility runs 24/7. They want the resilience of not just hours of backup. They do, of course, have a generator, traditional generator on site to back up the backup of renewable and utility. But this site is, even though it's a new building in a very developed area south of Cleveland, regularly loses power. So what the battery backup does, and the DC behind the grid distribution, really allows for a seamless transition between. Our microgrid systems design follow a architecture and goal of what we call prosumption. That is that you want to generate, store, and consume as much renewable energy on site as possible, relying on the grid as a backup. So wind and solar combined is an excellent mix, because wind and solar have opposite production cycles, both daily and seasonally. So for example, in the Midwest, when solar is at its peak in the summer, wind is actually at its lowest. However, in the fall and winter and spring, wind is at its highest, while solar generation is at its least efficient. So these two cycles play out even daily. There, where wind is better at night, in the morning, and solar is ramping up, wind is ramping down. And as you can see in this graph, the combination of the two, while we are operating lights, for example, and on the distribution side, which is typical when lighting is needed at night, we are using that stored renewable energy for the lighting loads. So it is a bit of a complicated graph, but at the end of the day, excess consumption is sent back to the grid. That can vary throughout the year, but these systems do have a very attractive return on investment, in addition to the comfort of tremendous battery backup capability. We were able to work early on with the building owner and architects, even to help orient the building for an optimal solar configuration for an east to west array design. East to west is really best, we have found, for storage, which prefers the longer charge cycle, just like a longer discharge cycle, than a traditional south-facing panel would be. We were also able to specify the roof paneling that let us use no racking, minimal roof penetrations. We kept those to only 8 on this entire building, and S5 clips, which also are efficient. At the entrance to the facility are 8 60-foot WindStax vertical axis turbines. These turbines are under the height restrictions, which is important. Traditional windmill could not be used here. We're only 3 miles away from Cleveland Airport, and also just across the street is a residential area. Traditional windmill could not have been installed here with the setback requirements and height restrictions. Our turbines, as you can see, operate from different wind directions, and they are silent. In fact, being based on drag instead of lift, they produce no vortex sounds or air pressure sounds that you would experience with a traditional windmill. And importantly to our customers, because we manufacture them here entirely in the US, we can customize, and we do customize our frame colors, and these wind turbine rotors are actually wrapped in 3M airplane quality wraps with the company's logo on them. This, as I mentioned before, Pitt, Ohio is a very vocal leader in trucking and sustainable energy. So they like to show off their renewable energy investments, and these 8 turbines make quite a statement as you enter this facility in Cleveland. This project uses Samsung batteries, a total of 1 megawatt-hour lithium-ion batteries, in fact, with a 250 kW power rating. The cabinet that these batteries and the entire battery management system are housed are out in the parking lot of the facility. The cables are run underground to a renewable energy room inside. But the beauty of these cabinets in this setup is they are completely self-contained. Each quadrant of batteries has its own HVAC system. Each quadrant of batteries, and in fact, each stack of batteries has its own fire suppression system and many other safety mechanisms and monitoring that goes on with these batteries. The voltage on these batteries are approximately 800 volts. So that allows us to take in the higher voltage of the solar and wind turbines into one central location. Again, because we were able to work with the architects early on, we consolidated all of the renewable generation and conversion and distribution into one central renewable energy room. That's a luxury that few of us have, but it does make for a very neat and consolidated approach to where you put your power electronics. In the renewable energy room, we reserve the center of the room for the power electronics and DC distribution bus overhead. The perimeter of the room we use primarily for distribution, fire safety controls, and the HVAC system. This room has its own self-contained HVAC to keep it cool. All of these components actually could have been outside. They are rated, have the NEMA ratings for exterior installation, but we choose to install these components inside whenever we can. So the solar system uses a 500 kilowatt charge controller, and we also have a distribution that converts the battery power from its variable voltage in the 700, 800, 900 volt range to a steady 380 volt DC output to a distribution bus. The heart of the system is a 250 kW bidirectional inverter capable of the grid tie, which allows for net metering, and also allows the system to call upon utility power if the renewable energy can't keep up with demand. In the renewable energy room, we consolidate the wind and solar generation into their own controllers. On the top, you see the 8 WindStax wind turbine controllers that are made by WindStax Energy. Here, they contain your fuses, disconnects, lightning arresters, and remote control. So we can control each turbine and each individual generator of the turbines remotely as needed. And the PV remote combiners are on the opposite wall, where we have 8 disconnects for the roof-mounted arrays with fused disconnects, of course, lightning protectors, and the carport array, which is an array off to the side of the building where there's a carport. Also part of the power control system, we installed a 84 kW rectifier that is a 480 volt AC grid tie to 380 volt DC to the grid backup. This unit is used for service, really. Normally this unit is off, but if we need to take the renewable energy system down for maintenance or service or for any other reason, we can tie directly to the utility to power the loads through this rectifier. So that's a full system backup. This rectifier, in addition, is tied to an on-site generator. So once again, the levels of resilience are important to this customer, and the redundancy in the system is here. Not shown in this slide is a 30 kW inverter that we have. Not all of the lighting, exterior lighting we could get in DC. So we do convert our 380 volt DC to 480 volt AC to operate all of the exterior lighting at the facility as well. All warehouse, terminal, and maintenance building high bay lighting fixtures are powered by the 380 volt DC bus. This also includes an outdoor pavilion, the exterior site lighting, which is stepped back to AC through our inverter, and the maintenance building uses this distribution all the way to the fixtures. These lighting fixtures also have motion sensors and timers on them, again, to improve efficiency. The rest of the building uses AC directly for the utility. So for example, the forklift chargers in this building are tied directly to the utility. The geothermal system and building-wide HVAC systems are all tied directly to the utility and do not operate on renewables. However, the excess renewable production does, we have found in the past 3 months of operation, offset the other utility loads that are not on the renewables as far as the net metering goes. The entire office facility at this terminal also operates on renewables. Here we step down 380 volt DC to 24 volt DC fixtures in the offices, the restrooms, and the cubicles. Even the egress lighting operates off of renewable energy. Pitt, Ohio, like many of our commercial customers, takes sustainability very seriously. So the offset on this facility, which happens to equate to 421 tons of carbon dioxide equivalent, is very important to them in decision making. The sustainability thread flows throughout the entire company, all the way to the employee level. So these figures are regularly published, regularly updated, and really part of what has become the sustainability goals for this corporation. That's very common, as you know now, particularly with corporations who recognize that sustainability is part of the strengths of their company, of their portfolio, and their customers and shareholders are demanding more accountability in carbon offset. So I pulled some live data from the system at Parma in September to show you a typical September day cycle of the state of charge of the battery, here shown with the blue line, and the system current shown with the green line. So beginning left at midnight the night before to midnight the day of the subject day on the right, you can follow me here, that you can see that the system current was steady actually discharging at night from the battery. As the sun came up in the morning, the system current increases fairly rapidly up to here over 300 amps. And you can see at the same time the battery state of charge, which we really try to maintain between 80 and 20% to maximize battery life, begins to rise as the solar energy begins to recharge it. You can see when the peak begins that the loads and the discharge rates drop back down below zero. So we are, this is showing the instance where the solar energy and wind energy at the time is not only, has filled the battery, is operating the loads, and what's not shown on this chart as a third line, however, is sending excess power back to the grid. So several periods throughout the day, when the state of charge of the battery gets to a certain point, you can see the cycle click up, briefly charge the battery back up while operating loads, and then back down to a discharge mode. So this is a typical cycle that we see in our renewable energy microgrids. Yeah, so I know you might be thinking that renewable energy systems, DC distribution at this scale only work at large commercial and industrial applications. But I can tell you that we really build our company on installing smaller scale microgrids. We indeed have a handful of projects at the residential level using wind and solar and storage. We have some smaller C&I projects that do take DC all the way to the fixture. Now I know you're familiar with how popular backup batteries have become in a traditional grid-tied solar system now with a Tesla's Powerwall, for example. But I would seriously consider taking it to the next level for DC distribution to the fixture. The efficiency gains are tremendous. And in addition to being an additional revenue source for your company, it is a real additional value to your customers to consider, DC distribution beyond the battery as well. On the other end of the spectrum, distributed energy resources can also benefit from this prosumption zero-first model. For example, in Pennsylvania, an additional 3.7% efficiency is gained by eliminating transmission and distribution losses where the electricity to come from the utilities. Ohio, that gain is up to 4.9%. The avoided loss is an additional external benefit to the environment and the customers by further reducing greenhouse gas emissions of traditional generation. That data is from the U.S. Energy Information Administration in 2018. But as you can see below, the addition of vertical axis wind turbines at a solar field actually can increase the annual yield of this field upwards of 20 to 25%. So this is something that should be considered even at the DER scale. In closing, I'd just like to say that prosumption is an investment, and this is a message that you would want to pass along to your customers and your potential customers. Electricity will always trend up. The Department of Energy has shown us that since 2013, 6% trend nationally is the national average, 8% more in 2017, a 3% annual in 15 years is projected. So investing in the prosumption model with renewable energy certainly hedges your bets against future utility price escalation. As power plants continue to close and even natural gas generation takes over coal plant or even nuclear plant generation, the cost of capital invested in new facilities must be borne by the consumer, all the way at the consumer level. So this is something that we're not going to see changing anytime soon. It doesn't matter how inexpensive natural gas becomes. The fact of the matter is the capital investment in improving or changing the generation, to natural gas and the associated distribution are going to continue to rise. If you'd like to learn more about renewable energy microgrids, vertical axis wind turbines, or DC distribution to the fixture, please contact me by going to windstax.com. On that webpage, you can also view many videos of our installations and a host of other frequently asked questions about our systems. In the meantime, thank you for joining us at North America Smart Energy Week, and have a good day.